25. If man is still alive, if woman can survive, they may find.
Hello, my name is Rod Kawicki. As you know, this video is about universal time. We're talking about time. There was another person who thought he could define time, and that man's name was Albert Einstein. He wrote a book called The Special Theory of Relativity. And in that time when he was publishing that book, he wrote 5 papers in physics. And one of them was about time. He believed that space and time were like sewed together. One didn't exist without the other one. And the fastest one can travel was at the speed of light. Anyways, he published a book on that. And what it did, it inverted the idea that time travel and a lot of other things were possible. That they could be mathematically deciphered, and he did that. And but this video is about his greatest blunder, actually, and a new definition of what time actually is. We could take the place we live, the universe as a whole, and decipher what to do with time, what time is. Now, Einstein's theory, first we'll talk about Einstein's time. Einstein's time was formatted on the speed of light and how fast the universe was moving, or gravity was moving. Now, gravity is the fabric of space. It's the stuff, the planets and stars and everything reside. They exist on top of this fabric that keeps them from falling anywhere. In other words, if the fabric wasn't there, these things they wouldn't float. Until they're like floating. But his theory makes it look like you look at the ocean and put boats in it, and there's different sized boats. And they all reside on top of this fabric surface. That was his idea. Whether there really exists one is predeterminate, let's say. But anyways, it's a good theory, the fabric of space. Anyways, he believed that time was associated with the space, and we can't travel faster than that. That phrase, nothing travels faster than light, in 1943 was deciphered wrong. That there was something that travels faster than light. So anyways, in 1905, when he published his book, it was about what he could imagine if you could travel at the speed of light. And what he did is he associated time with clocks, and each planet, which has a different size, but rotated and on the same fabric, had different times. There were different clocks. In other words, Earth, 24 hours, Jupiter, 36 hours, Pluto, 18 hours in a day. So anyways, all these planets have different time frames. But if you travel in a ship at the speed of light, according to Einstein, time ceased to exist. Time is zero. I don't know how he actually did that, but the easiest way to look at it is that you're in a ship and it's traveling 186,000 miles a second. If you do that for 5 seconds, you have had traveled 772 miles in 5 consecutive seconds. So where he said time did not exist, I don't understand that. Anyways, he made a mathematical equation that could determine the indifference between an event on Earth and a ship that was traveling at light speed. If you travel at light speed for 1 hour, Earth will have, you would have traveled into the future 80 years. But like I said, the easiest way to look at it is this. 5 seconds, a guy in college is running track, and he runs 4 or 5 feet in a second. You know, in 5 seconds he ran so many feet. 5 times 5 is 25 feet in a second. In 5 seconds, 5 consecutive seconds. Now, if you were in this ship traveling at light speed, you would have traveled in 5 seconds 772,000 miles. Consecutive seconds. So I don't see how time stops. You know, we have to look at this, not literally, but factual. You know, we got the equation. I don't see how you can take one of these equations and say, well, time stops because you're traveling at this speed. Besides the indifference of speed, the second hand's still moving in both events, and that's where the time is. Time doesn't actually stop. It can't stop. And a little ship, you know, can't change that. It won't change that at all. So anyways, he wrote a theory about time travel. It was what he did. But the events and the mathematics behind it. See, Einstein was good as an illusionist, you know, in his writing. His famous words in his papers were, imagine this, you know. But let's do the math. Come on. Imagine, you know, a guy jumps off the edge of a cliff and doesn't hurt himself, you know. In 1777 or 76, England, before America was discovered, thought the world was flat. That if you sailed into the ocean and you went too far, you'd fall off. Bam, you'd fall off. Now, Einstein is somewhat the same way. You travel at the speed of light. When you hit the speed of light, time stopped. Time ceased to exist. He even made a fourth dimension with it. Can time be a fourth? Yeah, it can be a fourth dimension, but it's based on length and it's based on velocity. Those are the main ingredients. Velocity, length, distance, like Newton's laws, and time, or velocity. But that's how Einstein changed the world. He changed the world because 30 years has passed before they literally discovered that something travels faster than the speed of light. But we're talking about time. Okay. Now, I wish you would take it literally that in a ship traveling at the speed of light, time still ticks. Because if it didn't, then how would he travel in 5 seconds 772,000 miles? I mean, how do you do that? Something's taken out of that, and the mathematics was taken out of it, and an explanation was put in its place. But anyways, we're going to talk about time and universal time. That was the only invention about time that exists at the time. Einstein was one of them guys that wrote a theory about time. But let's look at time as it really is. Okay, we have Newton's theory that anything at rest has a weight. You can measure it, you know. But the thing is, the universe is moving. That fabric we talked about is moving. And it's moving faster than light. And there's preferably a reason why it's moving faster than light. But before I get into any of that, if planets and stars were out there and space didn't move, wasn't expanding, didn't have a velocity, then everything would be at rest. It would fall, or whatever it would do, It would consist of having a specific weight because it was at rest. And because space has a velocity, a motion, is in motion, it keeps the 9 planets from falling into the sun. Now there's 2 ways to look at this. You have 9 planets and you have the sun. The sun is about 1,000 times bigger than all the other 9 planets together. You can take all those planets and stars and times it by 1,000 and you can put them all in the sun. So the sun has a lot of energy. But when the universe was born, all these energies consisted of a single ball, let's say. They were a cosmic egg. And it existed that way. All of it at once. When the Big Bang, or preferably in a collapse before the Big Bang, before everything exploded and left that singularity and started scattering through space, they were all one thing. And because they were all one thing, they were all one energy. So before we get into how time works, because they have the same energy, it's like taking a magnet, South Pole and South Pole, and trying to push them together. They don't want to push the other one, unless you got some kind of fence behind it or something, But without that fence, because there ain't no fences in space, there's a lot of space. You try to push those together and it don't work. And that's why the planets and stars are spread apart. And it's based on how much because of the same energy. It's called similar energy. And they're pushing apart from each other. That's one reason. The other one behind that is the universe is in motion. And this motion is greater than the energy content of the planets. So you have our 9 planets who can't fall into the sun because they are similar energies. We have energy and magnetism. It's called electromagnetism. And there's a force at play, and that force keeps them from falling all falling into the sun. That's one part of it. The other part is there is another force, and that's the motion. That's the velocity that space or gravity is traveling, the fabric of space, actually. That is gravity, and above it are us in these boats looking at the stars. But anyways, so we have similar energies keeping us apart, like the magnets. And then we have another force that is equal or more than the force that's keeping the planets and stars away from each other, keeping them separated. And they're separated more by this other force, and that's the momentum of the universe's motion. Now, we look at our solar system, we have the sun at the bottom. It weighs the more, or it doesn't weigh the more, it's the bigger one. And you have all these other 9 planets stuck in there, and what happens is we have a close separation of the planets, and if they were to fall away from the totality of the sun's energy, they would be attracted back, because it's not until the force of the elements and the energy of those elements move away that they're attracted to it. In other words, what I'm saying is they are attracted to the sun, but there's a limit. There's the force at play is inverse reaction, let's say. And above that, we have another force, and that is the universe in motion. And to look at it the way I want to explain it, if you take a ball and you're in a field, right, and you throw that ball and it hits the dirt, and you see the grooves that it put in there. Well, this is what happens to the 9 planets as they orbit the sun. There's a certain amount of energy that keeps them at a distance, but it keeps them there, And then the other force of the universe's motion, the gravity, is pulling them apart even further, because the force is expanding. It's getting bigger. So it's not a force of attraction, it's a force of keeping separated from the sun as a whole. And because it's separated and there's no concrete surface between the planets, I'm not talking about the surface of space, but the planets themselves. The energy content is relative to the energy in space, which is 0 point energy. So the mass is actually also zero. But because of the forces that play, they dig into they're pushed into the fabric, and they stay there and just roll. And that's how they get their orbit. Now, you've seen pictures of the planets and stars, and you got the sun in the middle, and you got rotation of planets, and they're all moving in different directions, around and around, right? And you have another picture where they're like straight across, right? So you look at it like this: you got the sun, the 9 planets, and without that extra force, they would act like electrons in an atom. They're surrounding the universe, but they all perfectly are kept separated from each other. There's a force at play. It's an electromagnetic force at play there. So you have that by themselves, but then you have the fabric of space to say, where are you sitting, you know? And its force is expanding, and it's expanding at a rate faster than the energy content of the matter that exists, which is E equals mc squared, that energy, that amount of energy. You can't go above that energy. But space, it's orbiting and at a greater speed than light. So it's taking the 9 planets and spreading them apart. And because they're on the fabric, they're laid out in a direction. And they have a direction of an axis, you know. And because they're pushed into the fabric, and they're rolling in that push, creating the access. And that's how it works. That's how the universe works. And everything Einstein said about the speed of light doesn't happen. There's no time travel. And all the luggage that he wrote down at the patent office and tried to put it in his ship and went out in space to explain all this, it doesn't happen. That was called his greatest blunder. And time in reference to the way I just explained our universe, see, all them planets and even the sun are actually in free fall. You know, the sun is bending the space, creating the hole that the rest of the planets are captured in. They're captured in this. And they can't get out because the sun's energy is keeping them in there because they're inside the same hole, but the hole's not there. It's opening up and kind of flat. Everything's at the same angle because space has increased the separation of the planets with the sun, and they're spread apart even more. They're spread apart perfectly 100%. You know, you look at Earth's gravity, you know, and Newton's laws, about 9.8 meters a second free fall, you know. And for some reason, that's always the same, but it doubles each time. Each time it doubles and it falls faster, it gets more energy, no energy. This does not exist in space, this free fall energy. The free fall energy is blocked off by the sun's energy, because the sun has 1,000 times more energy than all the 9 stars that are planets that are caught in its attraction, you know. And so you have this gravitation that's keeping them separated, and then you have expansion of the space, and it's pulling them even further away and deeper into the fabric and making it like a permanent cycle. We have everything's permanent, but it's expanding. The velocity of the Earth's expansion is increasing. And I have written a few books on the validity of traveling faster than light, because basically we have no energy in space, and you can make that, you know, all the luggage Einstein took up in the space doesn't actually exist. So, so we have a 0-point energy that makes everything weightless, especially a teeny ship, you know, compared to the planet. And it's not the planet's weight that sits in making the fabric, making it deep, you know. It's the motion of the universe's expansion. And that pressure is pushing against the pressure of space, which exists. Now, in my next book, I have a theory of why these indifferences exist. Not just the ones I'm talking about now, why they exist relative, let's say, to the creation of the universe, which was preferably the Big Bang. But I believe they collapsed first. But the numbers that I've used seem to line up, and if you noticed on my title, at the end of the title you got E equals UG, which is the universe gravity. Now time is relevant in measuring any of these events that happen. And my book goes into the biological content of the universe as well as, and how they, space and time, and how they all act as a whole. Everything acted as a whole because of the cosmic egg and the embryos that were created. Why is everything round? You know why everything's round? Like marbles, different sized marbles, And on Einstein's theory, he believed the universe to be flat. Now, I don't know if he meant that literally. He actually measured the length of the universe using the speed of light equations relative to the mass, and the universe has to be in billions, so billions of years. So, and anyways, the other theory created that they discovered FDL was possible, or the gravity of space is not only is it increasing, it's faster than light. And so what that does is, in that theory, the universe is round like a ball, and it's spinning. And that spin is also allowing it to expand. It's pushing everything around. Outward, like a balloon. So everything is not expanding like just outward. It's expanding from the center of the balloon, and it's raising the, actually it's lowering the pressure. The density is specifically the same because the space is the same, but a balloon, when you blow it up, you build in pressure, more pressure, and it's getting bigger. And this is why I firmly think that the universe started with the collapse before it exploded, and that the universe may be in its future have another terrible ending, another explosion. But anyways, hope you like my theory on time, and keep on listening. The quantum physics theories. Thank you very much.